Good morning, Cappuccino. Welcome back to IB Math. I sent out an announcement last night talking about what we're going to be doing this week. So first of all, I put a bunch of new assignments in MathSpace that are about adulting, so how to handle money. So those are all optional, but if you do them, I will give you credit for them, so that can help your grade. If you do them, I will give you extra points. Okay, but if you don't feel like doing them, you certainly don't have to. They're not part of the IB Math curriculum. I did decide, though, what we are going to do is we are going to do more calculus, because looking at the results of what kind of majors my seniors are going for in college, it looks like most of you are going to have to take calculus at some point when you're in college. Anybody who's majoring in biology will need at least 1 year of calculus, and anybody who's majoring in engineering will need at least 2 years of calculus. So let's do some more calculus. Let's get you ready for college. And then for my juniors who are going on to IBHL, you need more calculus as well. So it's a win-win. And I'm sorry for those of you who are not majoring in bio, sciences or engineering. You just get to come along for the ride. Learn a little bit more calculus. Why not? Okay, so our warm-up today is, you should know how to do this. This is going back in time. Find the integral and do it without a calculator, giving an exact answer. So in other words, it's not going to be very satisfying. And then do it again with a calculator and get your answer to 3 significant figures. By the way, when you're doing the answer without a calculator, what you can do is after you've solved it without a calculator, you can then use your calculator to double check your answer from A and B. You should end up with the same thing. But when you do it without a calculator, you're going to end up not being able to get it out to just a single number. You're going to have to leave it as an expression. All right, and then number 2, sketch the graph on the interval between x is 0 and pi, and then find the area of the region bounded by the curve and the x-axis in the following pair of lines. And go ahead, you can do it with a calculator. This whole thing can be done. Problem 2, the whole thing can be done with a calculator, but I do want to see a sketch. All right, so first 6 people who get me the correct answers on this will get extra credit. I want to go back to the last warm-up I gave you. This was on the Friday before our spring break, and I wanted to just go over the answer on this one. So we've got, I'll just do it right on here. So we have an adult of a certain breed of dog has an average height with a variance, blah, blah, blah. If the heights follow a normal distribution. So here's my key words right here. It's a normal distribution. So I know what I'm going to be using on my calculator. I'm going to be using that normal distribution stuff. So I have the average height is my random variable. The average height is normally distributed. And when we do a normal distribution, the first number is the mean, so the mean is 0.7, and the second number is the variance, so 0.05. And then we want to find the probability of 6 independently selected dogs of this breed exactly 4. Wait a minute, that sounds like a binomial distribution. Oh, so I'm also going to have a binomial distribution, and when we do a binomial distribution, the first number is the number of trials, so there's going to be 6 because of 6 independently selected dogs, so there's going to be 6 dogs chosen. The second number is the probability. Oh, I don't know the probability. I got to figure out the probability. Okay, so the probability of what? I want the probability that they are over 0.75 meters tall. So that I can get from my normal distribution. So back up here, I want to know what's the probability that x is going to be greater than 0.75 meters tall. Okay, so I'm going to do my normal distribution first using 0.75. And then after I get that answer, after I get that probability, that answer is going to fill in here into my binomial distribution. All right, so off to my calculator. So if I go to my calculator, I already did this once to make sure I could do it, so I probably still have the numbers in here. Normal distribution, so second Oops, you can't see what I'm doing. Second vars. We're doing the normal distribution first, so option 2. And I want it to be greater than 0.75. So if I think about that, if I were to graph that, hit 0.75, I want x to be greater than that. That's that way. Okay, so that means that my lower limit is 0.75. So I always like doing making the little graph to help me. Let's zoom in a little bit now. I like making the little line graph to help me figure out what's the lower and the upper boundary. So my lower boundary is 0.75. My upper boundary is infinity, so infinity, just put a really big number, it's fine. My mean is 0.7. My standard deviation, now here's where you have to be careful. I gave you the variance in the problem, so you need to do the square root of that. So square root of 0.05. That's the standard deviation. Then enter, 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 and I get the probability is 0.41153, etc. Okay, so put as many digits as you want because we're going to be putting that in here. Okay, so then I'm going to do my binomial distribution. This number is going to come down here. Actually, if I round that off correctly. Okay, you want to keep as many digits as possible when you're switching over to your binomial distribution. So now I'm going to get the probability of exactly 4. That's nice. I don't have to do the cumulative on that binomial distribution because that's kind of a little bit harder. I just want x to be equal to 4. Okay, so back to my calculator. Second vars. This time I need to go down and do the binomial distribution. And since it's just an equal, it's not a cumulative, I can just use option A. And 9 trials, there's 6 trials. P is the probability. The probability is 0.411532. X value, that's how many successes I want. I want exactly 4. And then I hit enter a bunch of times. And I get my answer. The probability of this happening is 0.149 or 14.9%. Oops, can't see that. Bam, there it is. Okay, so this was one of those sort of combination problems where you had to do both a normal distribution and a binomial distribution to get your answer. Okay, so good luck with this warm-up. Again, first 6 people who get it in get extra credit. First person gets 10 points. Everybody after that gets 5 points. And today's work, there's not going to be notes today, so there's not going to be another video. So let me show you what you are going to get. I'm going to be putting up this page from a textbook, the trapezium rule or the trapezoidal rule. And you are going to read it, and you are going to do this investigation, okay? So good luck. You'll notice something in here that looks familiar, okay? Basically, you're going to be finding the area underneath a curve. It's very similar to this warm-up, but you're going to do it in kind of a different way, okay? So the idea here for the trapezoidal rule is, what if you don't know the equation for the curve? What if you cannot figure out the equation for the curve? How would you figure out the area underneath the curve if you don't have the equation for the curve and you have no way of figuring out the equation of that curve? How could you do it and get a reasonable estimation of the area? Okay, so that's what this investigation is about. There is a question that you might have a little bit of a hard time with, which talks about percentage error. What is percentage error? So I'm not going to tell you, but I'm going to tell you, when you run into something that you don't know how to do, Google it. All right? So that's my big hint for you. If you don't know what a percentage error means, go and Google it. It's in there. I checked because I wanted to make sure that I wasn't giving you anything that was impossible to figure out. Okay? So if you're having a hard time with figuring out how do I find a percentage error, go ahead and Google it. It's not hard. Okay, so between what we do on this warm-up and what you do on here, you'll be able to figure out that percentage error. Okay, so that's it for my video. And if you have any questions, just send me an email. Okay, so I will have the warm-up, that's the only video, and then this will be on a PDF in Canvas. So on your mark, get set, math.